Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this session, I will share the test procedure. It is not written anywhere. It is my technique, how I work on these power supplies. When we are working, you see 1842, 2842, 3842, 1843, 2843, 3843, 1844, UC 2844, 3844, 1845, 2845 and 3845 series ICs. Basically these are current mode SMPS controllers. How we can determine that this IC is working or not? If it is not working, what can be the possible reasons? If we see these ICs, you see 1842 and 1844, these two families, this series and this series. Upper limit of VCC voltage is 16 volts and VCC off is 10 volts. You see 1843, 2843, 3843 and 45 series. The second two numbers, VCC upper limit is 8.4 volt and lower limit 7.6 volts. And if we see the upper two series, these have duty cycle 100%. The lower two ICs 50%. So all four ICs have different duty cycle, different voltage level. Difference between this one and this one, that working temperature. Otherwise all these ICs have same phenomena, same working technique. Either it is 1842, 1843, 3842, 384, whatsoever, 42, 43, 44, 45. Circuit configuration will remain same. Pin 5 of this IC will be connected directly to main ground, that is main capacitor, this smoothing capacitor. If you don't have good practical experience in power electronics, never do this experiment because it have live voltage. To turn on, to power on, this IC will need VCC voltage, supply voltage. Some ICs have built-in charging circuit, but in this family needs external startup resistor, because from here the transformer, primary winding, MOSFET is now turned off. When it is turned off, no current will flow, no voltage will be generated in VCC winding. In the first start, it needs this voltage. When this capacitor will charge at specific level, for this IC UC 4244, it will reach up to 16 volt. From 0 volt to 16 volt. Until 16 volt, this IC will remain off. Its internal latch will remain off. When voltage will reach at 16 volt for these two ICs, and for these two ICs 8.4 volt, 43, last number 43 and 45, when the voltage will 8.4, at that time that IC will start switching. If you are using this IC 42 or 44, that time it will switch at 16 volt. This resistor provides very limited current, so it cannot provide current for smooth operation, because when this IC will turn on, it will consume approximately 17 milliampere. But this resistor, most of the time it is providing 1 milliampere because it is high value resistor. When this IC will start switching, this capacitor will start to discharge. It will return back to zero side. and this IC will keep working until the voltage will reach at its lower level, that is 10 volt. This is time gap. In this time, if the IC starts switching, MOSFET is good, current will flow from this side to this side. At that time, auxiliary winding, VCC winding, bias winding will provide voltage, and this voltage will be rectified and it will receive at VCC pin, and this voltage must be within this window. If it is less than this IC will stop switching. Why? Because when the voltage will drop less than 10 volt, it will turn off. We can say to turn on, it needs this level. It is called VCC upper threshold, and it is also called overload protection, OLP, and this is under voltage lockout. If we are discussing this IC, at that time 8.4, 7.6. When this IC will turn on, this is on time. In this period, when the voltage are falling from 16 volt to 10 volt, in case of this IC 1842, at that time it must receive feedback. That means the MOSFET must be turned on. It must allow current to flow in the primary winding. Okay. There are other things for regulation, that is called feedback and compensation. In some offline switchers, there is no optocoupler connected. At that time, the same voltage will be provided to feedback pin. But in some cases, optocoupler is connected at pin number 2. Here is current sense resistor. When the current will flow here in this path, the voltage will drop here. When it will reach maximum up to 1 volt, maximum limit here, current sense, that is 1 volt. If any time, any pulse, because it is generating pulses here, at each pulse, a current pulse will here. If the peak level of this pulse is above than 1 volt, at that time this IC will turn off its output until the voltage are dropped to limit the current. So it is current sense pin. Anytime this pin is elevated more than 1 volt, this IC will turn off. Same way, if compensation pin is dropped, we can say around 1.4 volt, at that time this IC will turn off. There are two shutdown techniques. Normally this circuit will work like this, but for protection or some external power on off, these techniques are used here, that are here. Current sense pin, that is pin number 3. Normally it is receiving current sense signal from here. If an external transistor is connected and reference voltage, yes, when this IC will receive VCC voltage and it will receive this level, upper limit, it will turn on its reference circuit, that is pin number 8. It will provide 5 volt, regulated 5 volt. Here it will receive 16 volt, from 10 to 16 volt, but here at pin number 8 it will provide 5 volt. If any external switching transistor, any mechanism is connected between reference pin and pin number 3, it will turn on and reference voltage will be applied to pin number 3. This IC will shut down and it will remain off until it will drop less than 1 volt. R. The second technique, if the compensation pin is connected to equal to two diode drop voltage, that is base to emitter, base to collector, if one transistor, one SCR, thyristor, anything is connected, it will turn off. The IC will shut down. Then there is RT and CT. When it will generate 5 volt, timing resistor and timing capacitor will start to oscillate, and its internal switch will start oscillation. It will provide ramp signal, switching signal. This switching signal will reach at pin number 6 by processing from different comparators, flip-flops, to provide pulse width modulated output at pin number 6. It can be programmed by RTCT, or this IC can also be connected to any external oscillator. Like mentioned here, at pin number 4, if there is no RTCT, timing resistor and timing capacitor, we can see pin number 4 is connected to pin number 3 of 555 timer. Any type of timer, any type of oscillator, it will provide pulse and it will start. It need a signal here, either it is ramp signal, any frequency signal, so it will synchronize with external clock signal. At that time, RTCT will not be used here at pin number 4. In case it is switching and this IC cannot find this voltage, working voltage, what will happen? It will keep working until UVLO, under voltage lockout. When the voltage will drop less than 10 volt, it will turn off switching until the voltage will reach back again up to this level. When it will reach at 16 volt, then it will start switching again and capacitor will start discharging. This is called reboot mode, restart mode. It will start switching. When it will start switching, it will try to find the feedback. What is feedback? That are VCC voltage, and these voltage must be in this limit, above than 10 volt, between 10 to 16. If the voltage are more than 16 volt, this IC will turn off in overcurrent protection. That is called OLP, overload protection. It will understand that there are high voltage in outputs. If the voltage are less than this IC will not work, and it will switch in reboot mode. It will wait until the voltage will reach again. So in the output we will see fluctuation. Either it is using one output or it is using multiple outputs. That will the same. Either it is using offline switching method, that it will use feedback voltage from this auxiliary winding as a voltage divider network, or maybe optocoupler is connected here and some reference, any type of reference, Zener reference, adjustable Zener reference, whatsoever. At that time, when the voltage will reach at its maximum level, it will receive feedback that the voltage are maintained. When the voltage will drop, it will increase its duty cycle to create more magnetic field here. Here is one MOSFET, one switching device, 1844 series circuit and 1842 series circuit. Here it is using 2842, 2842, 1842, 3842, the same. But here it is using two transistors, two MOSFET. So it is push-pull DC to DC converter. It will provide pulse from pin number 6 and it will drive this push-pull driver. In some circuits we will see this UC2706, and most of the circuits don't use these ICs. They are using transistor combination to drive these MOSFETs in push-pull combination. If one will on, at that time the second will remain off. If it is on, this will off. So In one pulse, these will switch one by one. A feedback loop is connected here. Let's see this circuit practically. UC2842 series circuit. Yes, this one. This technique will applicable to all 4 series family, 424344 and 45 series. Here it is using 3842. I will apply power using series lamp. DC voltage. When we are working with SMD ICs, take care because there is very limited space between the pins. If you will make jumper bridging between 2 pins, so might be the IC will damage or circuit will damage. When we are testing, always take care for the safety, never touch the circuit because it have live voltage. Negative terminal of the capacitor and closer to pin number 7. Pin number 7 is VCC pin. That is here, VCC pin. VCC pin is connected to VCC capacitor. That is here. Closer to this IC pin number 7. That is this capacitor. 14.64 volt and these are stable. If it is fluctuating up down, the first condition, MOSFET is not switching. IC is switching, MOSFET is not passing the current to the transformer winding. So IC will consume the voltage from here, then it will wait until the capacitor will charge again. When it will charge, IC will switch. So it will be a reason to fluctuate the voltage. Second condition, if these voltage are not reaching from this winding or these voltage are below the under voltage lockout, its lower limit, it will fluctuate at this pin. Or if the feedback network is not good, its secondary side, there is some short circuit, there is any regulator that is bad, Zener regulator, adjustable reference, optocoupler, anything wrong. If there is short circuit in the output, any diode is short circuit, any capacitor is short circuit, the voltage will not maintain in the optocoupler side. This IC will not receive feedback. At that time, it will reboot again and again. When it will receive this voltage at VCC pin, at that time it will provide 5 volt regulated at pin number 8, common at main capacitor, and here is pin number 8. It is 4.98 volt. These voltage must be present. If these are not present, that means this IC will not start. These 5 volt reference voltage are necessary to start oscillation. If 5 volts are not present, this IC will not oscillate. It will not start ramp signals. One condition. Second condition. The third condition, that is compensation pin. Ground and pin number 1. Pin number 1 is now 1 volt. If it is pulled to 1.4 volt, it will turn off. This IC will turn off. Then we will monitor pin number 3. And here is pin number 3. Now it is 9 millivolts. As we discussed, if any transistor is connected between pin number 8 and pin number 3, any automatic control signal in case of overcurrent any condition or any manual signal, if these 5 volt reference voltage are switched to pin number 3, here it will elevate above than 1 volt, this IC will turn off. So these two conditions, if pin number 1 is above than 1.4 volt and this pin is above than 1 volt, this IC will switch off. If you have oscilloscope, you can connect between pin number 5 and pin number 4. You will see the ramp signals. And you can also check between pin number 5 and pin number 6. You will see these pulses, these drive signals. Then using multimeter, here is MOSFET, drain and source. Now check voltage at main DC capacitor, 329 volt. Connect drain to source. Why this multimeter is not reading? Now if I will check voltage here, DC voltage between drain to source, it is measuring 342 volt. 330 here at capacitor. Across this MOSFET, there will elevated voltage than this capacitor voltage. If we see, positive voltage are reaching through transformer winding and ground is connected to source. Between source to drain, there will be more voltage than this capacitor voltage. That means this transformer is in action. This transformer is switching. Its collapsing magnetic field is creating voltage stress on this MOSFET. And in some conditions, this MOSFET damage again and again. If it damage again and again, at that time we need to verify this circuit, that is snubber circuit. One diode, capacitor, resistor. If it is short circuit, diode is short circuit, it will cause to drop the voltage. If it is open circuit, the diode becomes open. What will happen? It will increase double voltage stress on this MOSFET. That are these components: diode, resistor, capacitor. In some circuits, there is TVS diode, transient voltage suppressor diode, that is connected across this transformer winding. So we can verify that diode. Same way, if you have multimeter, we can also verify the switching frequency. If your multimeter is responding to the frequency, we can check 52.89 kilohertz. If you are using oscilloscope, you can monitor the same 52.89 kilohertz frequency. If I will use this multimeter, it will not respond to frequency. Some multimeters have good response for AC signals and some multimeters don't have good response. So it will measure the normal signal, but here at frequency, common, pin number 4, it is measuring 550 kilohertz. This is ramp signal, 52.8 kilohertz. We can also monitor the frequency at gate pin with multimeter, but when we are measuring with multimeter, sometime it will cause to damage the MOSFET because its internal capacitance will make jumper. So if you want to verify the signal using multimeter, try to remove the MOSFET and then you can test the signal at the gate pin. That is best practice. But this is the best technique to check voltage at this capacitor and then check voltage across drain to source, DC voltage. And if you know any other technique, I will request to write in the comments, and I will personally thankful for your contribution. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.